In this lecture, we will learn about recursive functions. Recursive functions are functions that calls itself. I have here an example function. The name of the function is test. And you can see that in the body of the function, the same function test is called. So test is a function that calls itself. So this is an example for a recursive function. Now, why do we need to do this? That we will see with the help of an example. Let's write a function that computes the factorial of a number. Before writing the function, let us see first how factorials are calculated. We know that 1 factorial is equal to 1 and 2 factorial is equal to 2 into 1. 3 factorial is equal to 3 into 2 into 1. 4 factorial is equal to 4 into 3 into 2 into 1, and so on. Now, this 3 into 2 into 1 is actually 3 factorial. So I can write this 4 factorial as 4 into 3 factorial. The same way, 2 into 1 is actually 2 factorial. So this is equal to 3 into 2 factorial. Same way, 2 factorial is equal to 2 into 1 factorial. Or in general, you can write n factorial is equal to n into n minus 1 factorial. Now let us write a function for factorial. We have previously written function for computing the factorial of a number using loops. Now we are going to write a recursive function to compute the factorial of a number by using this idea. So let me start writing the function. The header of the function can be written as int, name of the function, let it be fact, and it has to take an argument, so int n. And inside the body, we know that there are two rules. If the number n is equal to 1, then 1 factorial is equal to 1. And all the numbers which are greater than 1, the factorial should be equal to n into n minus 1 factorial. So let me implement this in the program. So we'll write if n is equal to 1, then you have to return a value 1. Else, you have to return n into factorial of n minus 1. And that is our function to compute the factorial. So let me explain how this works. So if the number that you are going to give to the function n is 1, then the factorial value that it should return is 1. If it is any other number than 1 or greater than 1, then what it should give back is number into the factorial of the number minus 1, just like this formula. Now let us implement this function in a full program and see how the program works. I have copied the function fact here. Let me also add the main function. So int main, and I'll write one statement here to print the factorial, %d, comma fact. Inside that we'll give a value Initially let us give 1. Okay, and this is our program. So when you call the function fact1, this argument 1 will be copied to n, and if n equal to 1, so here n is equal to 1, it will return 1 at the place where it is called. Let me write that. So you make a function called fact1, then what the function will return is return 1. Okay, and this 1 will be sent back to the place where it is called, and this now will be 1 and that will be printed. Now let us input another number. Instead of 1, let us input 2 and see what happens. So you call fact2. When fact2 is called, 2 will be copied to n, and this condition is checked. If n value is now 2 equal to 1, this is false, so it will go to the else. So it will return n into fact n minus 1, and that return n is 2 into fact 1. So you see that the function again calls itself, so it calls fact 1, and when fact 1 is called, that 1 will be stored or copied to n. Again the condition is checked. If n equal to 1, it is 1 now, so it returns 1. So let me write that. So this function call will return 1. So when it returns 1 in the place of fact 1, what sends back is 1. So this return 2 into fact 1 changes to 2 into 1. That would be finally returned to where fact 2 is called. So this will be 2 into 1. So eventually in the place of fact 2, what is returned is 2 into 1, and that would be printed. Now let us input one more number and see what happens. Let us input 4 and let us see how this program works. So you make the function called fact4. So when the function fact4 is called, 4 will be copied to n, and first this is checked. If n equal to 1, 4 is not equal to 1. So this is going to return 4 into fact3. Let me write that. First this return 4 into fact3. Again when fact3 is called, this 3 will be stored into n, and again the check is made. 3 equal to 1, it is not, so this returns 3 into fact2. So let me again write fact3 return 3 into fact2, and when fact2 is called, 2 will be copied to n. Again this check is made, and this return 2 into fact1. So fact2 return 2 into fact1. Again when fact1 is called, 1 will be copied to n. So if n equal to 1, n is now equal to 1, so 1 equal to 1 is true, so this returns 1. So fact1 is going to return 1. So when this returns 1, fact1 becomes 1, and fact2 becomes 2 multiplied by 1, and fact3 becomes 3 into 2 into 1. and fact 4 becomes 4 into 3 into 2 into 1. So this is how recursively the function called fact is made to obtain the factorial of a number. Another way to understand this is when you make a function called fact 4, what you're going to get is 4 into fact 3, and fact 3, as you know, is 3 into fact 2, and fact 2, you know that is 2 into fact 1, and finally fact 1, you know that is 1, and you get the 4 factorial as 4 into 3 into 2 into 1, which is 24. So here this function fact is a recursive function because it calls itself. This phenomenon is known as recursion. Recursion simply means repeating a process to obtain a result. You can also classify recursion into direct and indirect recursion. In direct recursion, the function explicitly calls itself, whereas in indirect recursion, a function calls another function, and that function in turn calls the first function. Eventually, the function A calls itself, but it is indirect. Now, let us summarize. A function that calls itself is known as a recursive function. In direct recursion, the function explicitly calls itself, and in indirect recursion, the function eventually indirectly calls itself. Hope you have understood the concept of recursion and how to write recursive functions. Thanks for listening.